think we're good to go. No?
Yes. Yes.
Right.
Yes. You can start.
Okay, then hello everybody. Today we have welcome to this nice teacher seminar. Today we have Laura González, and she holds his bachelor in aerospace engineering from the University of León. Then she moved to Sydney. She do a lot of things that she will explain to us. Then she's also volunteer of the STEM Talent Girls, Inspiring Girls, and is the national contact point of the Space Generation Advisory Council in Spain, organizing events and supporting the community of passionate space students and young professionals. And well, this is also a topic that we are also from the equity committee to let's say to explain and then to bring in people as Laura. So Laura will talk about the thermal ice and Hypatia. And then please, Laura, the floor is yours.
Thank you very much. Thank you very much, Pepe. Thank you very much, everyone, and ICE-CSIC for inviting me to this pizza seminar. I think it's a great initiative. So yeah, thank you so much. And please, yeah, don't be afraid of coming to the first rows. I don't eat yet, so yeah. All right. So yeah, we're gonna talk about two topics today, and I was trying to see a connection between the two of them. And to be honest, it's only maybe me and my passions that is the connection. So we will talk first about thermal analysis and then about the Hypatia mission that I think could be of interest. I know all of you here are very renowned scientists, so apologies if the talk might not be so scientific as the ones that you're used to, but I hope you find it interesting, and any questions we can also talk at the end. All right, so I'm going to start with a quick introduction about myself and my trajectory and career. I'm from León, a small town in the northwest of Spain, and I studied there aerospace engineering. I was always very passionate about a lot of maker spaces and 3D printers. I was a little bit of a geek, to be honest. So I was working in many extracurricular projects and a lot of student societies that I founded regarding maker spaces. Then I moved to Madrid to do my master's there. I was also involved in the Formula Student Car and a lot of other projects. And when we were finishing the master's, we were started Radian Systems. It started as a project. It was a few students that we realized that the thermal analysis tools that were out there were very complicated to use. And we thought, oh, I'm sure that there's a way to make this more agile and simple. So we decided to create what was a project and then evolved into being a company. So we incorporated Radian in 2019. That's when we started the company. At the same time as Radian, from the beginning, I was always doing Radian with another job because startups are hard, and as you might know, so it was difficult to be working only for the startups. So I had other jobs. So I worked at INTA, is the Institute of National Technical Aerospace in Madrid. So I was there involved working there in two science missions for the European Space Agency. You might know Plato and Athena. So those were the missions that I was working on as a systems engineer. I was super lucky to get to work also as assembly test and engineer in the clean room, so assembling parts of the focal plan assembly of Plato, for example. And that was really, really exciting because you're touching parts of a prototype that is going to be launched to space. I'm sure that a lot of you have that experience here, and is really, really interesting. And then I moved to the UK. So this was in 2020. It was Brexit, and it was also the pandemic. And then I decided to move to the UK. My mom was very not very happy about it, but I really enjoyed it there. So I was working for Satellite Applications Catapult, and this is a company that supports the ecosystem there in the UK. So trying to create business opportunities, but also a lot of hardware. So they have a lot of testing facilities, vibration tables, or thermal vacuum chambers to allow the industry to grow, especially new space startups and small startups that need this type of equipment. So I was there first as a space systems engineer, and then my role evolved towards being the space manufacturing lead. So I had a small team. We had lots of manufacturing equipment, including a metal 3D printer. As I was saying before, I'm a geek of 3D printers. I always loved them. I was working with plastic 3D printers when I was at uni. And then in the UK, I had the opportunity to work with metal 3D printers. And with this particular 3D printer, we were building rocket engines. And that was also pretty exciting because these rocket engines are already in space, and they were mostly for in-space propulsion. So this was the technology we were using. And as you know, 3D printing, additive manufacturing is really interesting when it comes to printing very complex geometries. And there's a lot of designs that wouldn't be able to be manufactured if it was not thanks to this technology. So it was a technology that allowed us to really develop and support companies over there, because a lot of these small space companies, especially there in the UK, they didn't have the resources to invest in this type of equipment, but we were providing this equipment and supporting them there. And I was there until a bit earlier this year. So in February 2024, I managed to come back to Spain. I'm actually based here in Barcelona. And after combining my role in Radian with other jobs I've just saying for a number of years, now I'm fully focusing in Radian, my startup. So I'm very happy about it. And my main role there is the commercial side of things. So we have a technical team that has been developing a software that I'll tell you a little bit more about. But I manage the relationship with the users and the potential customers, and trying to make the software also a little bit more easy, accessible, and finding all of these improvements that we can do to support. And so also on the side, let's say, I've always been very interested in doing many things. And now with Radian, I also do a lot of things, but these are more in my free time activities, let's say. So yeah, Pepe was mentioning before about Space Generation Advisory Council, and that is a non-for-profit organization that started in the UN to show the voice of the young professionals and students in the UN regarding space topics. And so I'm the national point of contact there for Spain. So we try to organize events and try to create this community of young professionals in space that are very interested in doing more activities and getting together. And then I will also tell you a little bit more about Hypatia. And this is a mission that I've been very lucky to be selected for next year. And I think it could be interesting for you to hear a bit more about it. So the way the talk is gonna be is I'm gonna talk a little bit more about thermal analysis first, and then we'll move to talk about Hypatia as well. Right, so Radian, what is thermal analysis and where in the process it is? Well, you all know about this. When we have a space mission, these are some of the steps that we follow in terms of first the design, and then we go towards the manufacturing, and then the operation of that mission. Thermal analysis usually sits in the design and also a little bit during the testing that is done in the manufacturing phases. And as you know, in a satellite, in a space mission, there's a few different subsystems. Thermal analysis is one of them. And so it's very important that there's a lot of communication between the different teams and thermal analysis team, that it tends to be also the last one, because you need to have a whole mission almost a draft ready. So there's a lot of back and forward there. And sometimes we're a little bit unlucky and we're the last ones to come into the mission, but it's a very important part of the process. And why is thermal analysis important? Well, I'm sure that you all know this, but when a satellite is in space, it's exposed to a very wide range of temperatures, going from the hundreds of degrees Celsius to minus hundreds when they're in the eclipse area. And it's not only the sun that affects these temperatures, but also the planetary radiation, reflected radiation. So there's a lot of different variables that we need to take into account when we do thermal analysis. And then based on this thermal analysis and the results, the thermal engineers can manage to think about different solutions to be able to maintain these electronics within the range that they're designed to be operating, so that all the systems can continue functioning. So thermal analysis is not something new. It has been done for a number of years already, but something that we're experiencing now, and I'm sure you all know about this, is a revolution in the space industry. So very similar to the revolution that we had with computers and the computing capability that we've had with all of these devices, something similar is happening in space. Mostly due to the miniaturization of electronics, but also thanks to the lower costs of getting to space and access to space with rockets that are now reusable, for example. Now we have the opportunity to have even universities or smaller organizations launching satellites to space. So these satellites are not maybe as big as before, and it's not only NASA or ESA that are able to do this type of missions, but also the space is open to new players, and you all know this is called the new space. And what we realized is that even if we had this revolution in the space industry, the thermal analysis tools that people were using were still very, very old and they were not adapted to this new revolution. And when we have these type of missions, as you know, the sizes and the scope has dramatically changed. So before, in the traditional space industry, we had very, very big missions, very long development times as well, and large, super large budgets. But now with new space, we're talking about really, really reduced development times and also budgets. And as I was saying here, the thermal analysis tools that were available then were not adapted to this at all. And that's why we decided to develop Radian. It started as a project, as I was mentioning, but our main goal is to make thermal analysis easier for the thermal engineers, because we realized that all the formulas, the equations, it was all in the books. The only thing we needed was a much easier user interface so that the engineer could do engineering and not fight with the software that it was very difficult and spend maybe 6 months learning how to use this new software, right? So we tried to make it more accessible in that sense. So not only for organizations and universities as well. So in universities, you have CubeSat projects that can use our software, but also there's a lot of space systems design courses or spacecraft design, in which we're already working with several universities, both in Europe and in the US, and they're finding very interesting that with a few clicks, you can design a mission, see the thermal analysis, and then think about the solutions. A little bit in a glance, we started the company in 2019, and it was in 2019 when the first satellite with our thermal simulations went to space. And then since then, it's been more than 30 satellites that have reached orbit with different organizations from Europe. In Spain, we work, for example, with FOSA systems, with INTA. In the UK, there's Spire, that they do nano satellites, you might know about them, or STFC, RAL Space. There's different organizations that are already working with our software. The main use cases we have is satellite developers, but also universities, as I was mentioning. And we also work with different components manufacturers, because we have a big data bank. It's kind of a catalog in which we have different parts that the user can take and then reuse for different models and make it much more easy, kind of a Tetris style in which they can configure their satellite. In terms of platforms, there's different uses. We're working from one Pocket Cube unit towards 16 use as well. That would be the maximum that we've worked, or our clients have worked with in terms of satellites. But now we're moving also towards microsats, so bigger platforms, and there's actually no limit in the computation, because Radian is the first cloud-based software that exists in the industry. So there's actually no limits in terms of computations. We can use more servers and expand in that sense. This would be the first satellite that reached orbit. Sorry, this slide might be a bit old, but here we did also a case study. So the software has been validated in orbit, not only with this satellite, but with many other satellites that have come after that. And here you can see some of the telemetry, so the data that we collected from these satellites in orbit that corresponds with the thermal analysis that we performed before here on Earth. And you can see that we had a very good accuracy, 99.3%. We're also working with the European Space Agency. So we currently have 2 projects with the European Space Agency with the team that is doing thermal analysis and verification. The first is the validation of our simulation engine. So we have already validated it in space and also compared it with other thermal analysis tools that were out there in the market. But some of our clients are still asking us for more validation. So we're working with ESA to have the software validated and have a report, and hopefully even a stamp from there, from this team. And then we're also working in a project about exchanging thermal data. So this would mean that we can do, for example, projects with Radian and also exchange it with other thermal analysis tools, and similar to STEP that everyone works with for 3D modeling. This is something that the European Space Agency is pushing a lot, and we're supporting them there in this effort. Some of the software features, I don't want to bore you too much, but there's a big data bank, that's the catalog that I was mentioning, a ray tracing engine, and well, I can go into more detail if there's any interest in particular later, we can go through them. And in terms of performance, these are some of the numbers. In terms of nodes, the maximum number of nodes we're currently working with is around 1,000 nodes per model, but that can be improved in the future. And this is something that we're constantly trying to improve. when we started Radian, we were very lucky because we were starting from a blank page, let's say. A lot of the softwares that were out there has been there for years. So what they tend to do for software development is just put patches on top of patches, and is still not very intuitive. But in our case, we were thinking, okay, what does a thermal engineer do, and how can we make this process logical and interesting? And so we started first with the model. These are the 3 steps we have: model, the scenario, and then the case analysis. In the model, we create the geometry. So this is the view that we have in Radian. I could give a demo in the software, but I think it will take a little bit longer. So I'll just show a few slides. But yeah, this is the model and the model creation. So you create the geometries from some shapes that we have in the geometry builder. And then you simply select the material and the different properties that you want over there with the nodes and the surface treatment and so on. Then in the next one, this is where we create the scenarios. So we have 2 types of scenarios, the orbital scenarios, but also the enclosure scenarios. Orbital scenarios, the typical one that we're all used to, where we have an orbit, so you can define the orbital parameters, and then you put the duration and so on, and you end up having this orbit. And then the other enclosure scenarios is mostly thought for thermal vacuum chambers and thermal testing, even payloads that are integrated in a bigger platform, and they have this envelope from the platform. So that's why we created this other type. And then finally, this is the type of results and post-processing that we get with this type of plots, in which you have all the information from the temperatures of each node at each point of the orbit. And you can hide them all, also show the different parts and the maximum, minimum, average temperatures, all the information that the thermal engineer would make there. And the last thing I wanted to mention regarding Radian is that we have recently implemented a new feature that is the CAD importer. And this is something that everyone was asking us from years and years, since 2019 when we started the company. We finally have it implemented since a few months ago. And the way it works is that it takes the original file and then it simplifies it so that you can have a model automatically almost generated. So you don't need to invest a lot of time doing the design itself in the software. So that's been our goal all the time, is to make it simpler and very agile to do this type of thermal analysis. And you can see here from 2,500 parts to 43 geometries, how it's simplified. So thank you very much for listening to that. If you're interested in Radian, this is my email here. And we're actually doing a webinar in 2 weeks' time, in which we will talk about how Radian is used for universities in particular. But if you're interested, just shoot me a message and I'm very happy to show you the tool. We also give free trial periods for people to try it and get acquaintance with it. So I'll be very happy to talk with you about that. And just to finish briefly, this would be the second block of the talk. And when Pepe asked me to talk about Hypatia, I was very happy, because I think it's a very great project that we need to talk a little bit more about it. So does anyone here know about Hypatia, about this project? 2 people. Okay, that's good. No, we should definitely improve that. So Hypatia is actually a Catalan project. So it started here in Catalonia. And the idea is to, well, I'll show you this trailer. It's supposed to be Mars. It's not actually Mars. But this is the desert in Utah. Yeah, so what you saw there is the last mission that the Hypatia team did last year in April 2023. And I'm very happy to have been selected as part of the next mission that will be next year, so Hypatia 2. Hypatia is a project. Hypatia Mars actually started as an association in 2021 with the goal to promote STEM careers, especially among the little ones, right? Not only girls and women, but also everyone, just to promote this type of careers. And we have 3 objectives, as you can see here, is research, quality research, then outreach, and also this creation of role models for little girls to be able to think that they can be able to do whatever they want in the future. So this is, sorry, it's in Spanish. I should have changed them before. But the reason is why Mars. In order to get to Mars, we have a journey of 6 to 9 months, right? So it's very important not only that we prepare for the very hard conditions there, but also to be able to stay. So for that reason, we have this type of analog missions in which a group of astronauts, analog astronauts, stay time there in the habitat that is already prepared, in this case, in the Mars Research Desert Station. It's in the desert in Utah, and the objective is to go there to do research experiments. And this is also an invitation if you have any ideas of research that can be done in February 2025. We're at the moment working in these type of projects, and we actually have one of our colleagues in the mission, in the crew, is actually a researcher with not rocks, but yeah, it's like Martian rocks. So she's actually working on some of the samples from Apollo. So she worked with NASA, and she knows a lot about these type of things. So we have a lot of different researchers in different fields. And so if you have any ideas of things that can be simulated in Mars, please let us know, because things from, yeah, rocks to biology to astronomy, there's a lot of different research fields that would like to try to simulate there in simulated Mars, especially around protocols. That's something that is super important. So for example, communication there is restricted. So we have a very long delay that simulates the delay and the lag that we will have in Mars. And also we always try to document everything. We have protocols, and you'll see also a normal day in Mars. But here's what we have in terms of the habitat that we're going to be at. We have this big hub, and that's a 2-story building with, I think it's 8 meters diameter, and that's where the astronauts spend most of their time. And they have like 2 different floors in which they do everything from sleeping to planning to some of the experiments. Then we have different locations. Here we have the repair module, because this crew needs to be totally independent. So anything that breaks, anything that we need to make ourselves, it needs to be repaired here. We also have a greenhouse, so that's where we cultivate our own vegetables. So diet there is very similar to astronauts' diet. We have all dried food and this type of food. And we also have our own green hub where we cultivate some lettuces and cherry tomatoes. So it's an interesting experiment. And then we also have a science dome, and that's where most of the experiments are done, and an observatory that you see over there. A lot of them, some of the activities that, well, this is just me being a fan. So even before the crew went there in 2023, sorry, they went last year in August. I got the chance to go to SmallSats. That is a conference there in Utah. I don't know, have you ever been to SmallSats? Anyone here? Well, it's a very interesting conference there. And so I think it's 3 hours away from the Mars Research Desert Station, but I couldn't help it. So I had to go there and see it with my own eyes, and took lots of pictures. And I was like, oh, I wish someday I can do an analog mission here. And so last year is when the first mission went, and I was following them and being a fan. And I'm very happy that I applied to the second one and I got in. But this is the crew that went last year. You might know some of the faces here. Yeah, I see some people recognize some of the faces. So they're all from here, from Catalonia. And in this year's mission is all Catalans except for two people from León, actually. It's very funny, I don't know why. The 2 of us are from León. And so yeah, here we have from scientists to engineers, a lot of different skills, including also outreach and journalists. So it's important to show that we have a very diverse pool. And as you can see, it's also very diverse in terms of the ages. So there's no range of age. We want to be able to have, people that are maybe in their 60s to people that are, I think youngest is like 21 or something. So we can show different role models, but also in different ages as well. These are some of the extracurricular activities. So we have a rover, that is the one that you can see over there. And some of the activities that the astronauts do is have these excursions in which they go with the rover, and they go and try to find some location where there might be some interesting rocks, and then they bring it back. And here's a few more images. So this is, for example, what they would look like for these astronauts. It's a lot of exercise. As you know, astronauts, at least in the International Space Station, they need to do 2 hours a day of exercise. But imagine doing exercise always inside the room. There's no like running around or anything. So it's a very conducted exercise that they need to do. And then you could have like different projects or AVA, that would be the extracurricular activities. And at the end of the day, there's usually the reports that are sent to Earth. So everything is reported, and we have very strong documentation requirements. And yeah, this is a few more pictures of the last crew, where they will take in some rocks and then analyzing them in the lab. And also the cultivating the science stone that I was saying before. Some of these, they were used for them eating actually, or just research depending. And a lot of research also on the human body, just to know what does it do to be 1 week. For us, it's only 1 week. There's other experiments that are maybe half a year or more, trying to simulate what it would do to a human being to be isolated in this type of conditions. Yes, so now is the turn of Hypatia 2, and that would be the mission that I'm very lucky to be part of. So I'm a backup engineer, but we have people from all sides. So there's all Catalan except for Jenny and myself that we're from Leon. And you can see, for example, Adriana, she's the commander. She works at NASA in the Goddard Space Flight Center. And we have from engineers to nanoscientists, Monica Roca, you might know as well. Well, there's a very variety of roles and people. Marina is the one that I was mentioning. She works with the polar rocks. And we have Elena, she's the youngest one in the mission, and she's an engineer as well. So very different roles to try to also each one of us contribute with our own skills. And just to finish, I wanted to also invite you to an event that is tomorrow in CAISA Forum. And this is organized by Women in Aerospace. That is also a very interesting organization that I invite you to research and to become part of, because they promote a lot this type of activities, not only for women, but for all of us to have a more diverse society in space. And I think that's it. Thank you very much. Maybe I went too fast, but it has more time for questions.
Which are the differences between Hypatia 1 and 2?
So one of the difference, Hypatia 1 was created as an initiative, and it was the first mission. With Hypatia 2, what we want to do is also instaurate it more as a project. So it's not only one thing, but it's actually something recurrent, and hopefully every year we can have a new crew going towards I was going to say Mars, but no, the Utah desert. The main differences will be with the projects. So the projects that they did were more related with, as you were saying, like the human body and a lot of biology as well. In this case, because we have new profiles, we try to give it a new angle. So it will be a lot more professional research on rocks, because we have Marina, and then we will have other projects, for example, related with 3D printing, with communications as well. So in the previous mission, Mariona, she is studying exoplanets, and she's very, very good at astronomy topics. So she did a lot of research in that area. In this time, we will do other type of research. So it's mostly the research.
Yes, please. Thanks for the talk. I have a question regarding the thermal analysis part. So, as you mentioned that you have to simulate the planetary emission as well. So can you shed some light on it? Like how do you do that?
Yes, these are all values that are inside the software, and different planets would have different infrared. It's basically the infrared that the planet emits that it's relevant to the satellite. It's usually a very, very small contribution when you compare it to the solar contribution, but it also plays a role. So for example, the Earth would emit different infrared values than Mars, and with our software you could simulate it both in the Earth, Mars, and sometimes we have students or universities that ask us to put like an asteroid, and so we can also simulate that, and it would be different values, not only with the diameter, but also this specific infrared planetary radiation that comes from the planet.
During the AVA, do you breathe air from the atmosphere, or is it directly from the model?
They go with a big suit, but I believe that suit has probably ventilation, because I don't think it would be cool to do something, for example, like doing scuba diving or something like that. But at the moment, I believe it's just a big suit with some ventilation, so you're actually breathing normal air because we're in Utah, not in Mars. But the idea is that it's a very difficult suit to put on. So the whole protocol of like getting dressed up and coming back, and you need to also give communications back to the base every 30 minutes. So maybe you don't have good connection, so you need to go with the walkie-talkie and try to find a place where you can reach back to the base and say, hey, I'm alive, I'm okay. So yeah, but in terms of breathing, I believe is normal air that you're breathing. Thank you.
So what do you have on Spanish?
That's a very good question. I think the idea is to expand it more. I think it started here in Catalonia because the team that was promoting it at the beginning were all from here, and they found a lot of support in the local entities, like the Generalitat de Catalunya and La Fundación La Pedrera. They've been the main sponsors for the first mission. But I believe with this next mission, we're opening a bit more the scope, and in the next ones, I would really like to see it opening even more towards Europe or other locations. I don't think there's any restriction on the location from the people that apply. When I applied, I wasn't sure if it was only for Catalan, for example, but I applied and there was no restriction. So perhaps if someone from somewhere else in Europe would apply, they might have been already selected for this Hypatia too. Because I don't think there was any restriction. But
Supported by the Generalitat?
yeah, the first mission was, and I believe the second one will be as well. So we're now in the phase of finding the sponsors and support, because these type of missions, they are pretty expensive. So we need the support of different institutions. Yeah, if someone else from Paris might have applied, and maybe if they passed the application process, I'm sure that they will be here as well. I don't think there's any restriction on the location from the people.
But in Hypatia, you're going as a reserve engineer.
Yes.
That means you will be waiting in a room.
Correct. Yes. Yeah. Sorry, I went too fast. I should have explained that a bit better. So I'm a backup engineer. So it's nine people have been selected. I think they have too many applications from engineers. So unfortunately, I'm a backup, which means that I will be based on Earth, so here in Barcelona, and I'll be the comms really. I'll support the team from here for this mission, but then I'll have the chance to actually go to the Utah desert the next year. So it's kind of a long-term mission for me, in which I will be back supporting from here, and then hopefully in February 2026 I'll go physically there, unless any of the of my colleagues are unable to go for any reason. Then I would jump in and be part of the team.
A question not related to that project, but I remember that more than 20 years ago, it was something like Biosphere 2 or something that they created in Arizona, a huge structure for isolated group of people, and it failed. And now we got this, and do you know if there is any other simulation like Hypatia goes in that direction to check how people behave and react in isolated environment?
Yes, 100%. So this base that we're going to, the Mars Research Desert Station, is actually started by the Mars Society, and it's a global society, and they have this base, and this base is always used. We're not going to create any infrastructure. This infrastructure is all there. So different teams from all over the world, they go there and they do their own analog missions. And it's not only this Mars Research Desert Station in Utah, but there's also another one in Hawaii. This is called ICE-CSIC. There's others. There's one even in Santander, where they go inside a cave and then they do this type of missions there. So it's worldwide. There's I wouldn't say big, but there's a community of analog missions in general. For us, it's more like amateur, let's say, because we all have our own jobs and our own main activities, and this is something we do more on a side. But there's researchers and professionals that are actually doing this. Even NASA is doing experiments in which they have people for, I don't know if a year, but long periods of time in a much more, medical, professional way. I'm not very sure about the project that you mentioned, but I will investigate and research a little bit more about it. I'm sure that even if it failed, there was lots of learnings, and I'm very curious to know why that one failed in particular. So I'll research a little bit later.
didn't have a comment on this. It didn't fade really. I read I'm not working on that, but I read about it, and actually there are tens of papers on things like psychology of group.
I didn't know that they faced on research, but then it was supposed to be longer, but because of some conflicts and other things.
It ended up with financial issues and all sorts of yes. Bad things. For example, the environment was closed for almost 2 years, and there were issues that were identified. Some colonies of insects died for no reason. They had to explain when that happened. Oxygen levels started to drop because materials absorb some of these things that do not, the problem with project is unknown unknowns. So this helped that. Maybe it was over expensive and a bit to review project.
It was very ambitious.
Yeah, it was very ambitious. It's still there, the infrastructure. Actually, can be visited and we can also apply for it. And it's now owned by the state.
Thank you. That's very interesting. Yeah, I think there's a lot of challenges there. So even with NASA, with the Artemis mission, for example, is going to put the first woman in the moon in 2027, but the moon is just a stepstone towards Mars, right? So this the Moons to Mars mission that they have, I think is super interesting, not only for the technical challenge that there will be a lot, but also for psychology challenges, or how do you behave with a number of astronauts that you're going to be stuck with for a very long time in a different planet with all the challenges that entails. So we feel like there's a lot of research to be done also in the more society part of it. And in our team, for example, we have Jennifer. She hasn't done any science before. She's a journalist, and she also studies a lot society, and that's super important for us, not only for the outreach, but also to see how we behave between each other, and in general in this mission is going to be very important. So it's very interesting.
The talk. It's really interesting and that's very nice. So I have a couple of questions. Maybe I missed it. Sorry. How the results and the experience in general of the first departure have been disseminated? Like, have you published anything, maybe documentary or article?
Yeah, so the team has done a very good work with a lot of press releases. So there's a lot of information in the press because they want to reach out to more people. We do a lot of schools outreach as well. So we have a kind of a project manager, one of our team that tries to organize it, and when we have requests, we go to lots of the schools. And there's also some of the information regarding the projects is already in the website. So we have a website. If you look for Hypatia Mars, you can go to the website and find there all the information from the past projects, and we're currently working on the next project. So if each one of us in the application process, they asked us not only about our roles and our CVs and information, but actually the most important thing was that they asked us about the projects that we would implement when we go to Mars or to the Mars Research Station. And so now we're working on those projects, polishing them more, and we want to do a lot of outreach as well, not only during the mission, but even before and after, in terms of events, going to public schools in general, but also reaching to the public.
Could you, I see, are you working in the Radian systems? Could you provide more information about the company?
Yeah, so we started in 2019. It was, before we incorporated the company, it was a project that we started with some colleagues at university. From that group of colleagues, it was only 2 people that we were left when it came to the step of incorporating the company, because I think startups and entrepreneurship can be scary sometimes for some people. So it was only my other co-founder, he's the CEO of the company, David, and myself when we started. And now we're 4 people. So as you see, we've grown a little in these years, but we've been bootstrapping. So with a lot of the new space startups, they tend to grow very quickly. And that's usually because they get investment. In our case, we haven't had any investment. We wanted to build a company that grows organically from the sales that we have. So yeah, we've been growing very little by little. That's why at the beginning I had to combine it with other jobs, and I was in the UK and also in INTA. But now finally we're in a much more stable position. We got selected by the ICE-CSIC, it's the incubation center in Madrid. It's an incubation center the European Space Agency has in Madrid. There's also one here in Barcelona, but we got selected last year, so that gave us also a little bit more robustness, let's say, and we're continuing work growing. We actually want to recruit someone else for our technical team now, so it's a small team, but I think we have great ambitions and we're growing little by little. The main service that we do is provide licenses for our own software, because that's what we've developed and we've keep improving over the years. But we also do consulting in terms of thermal analysis. If any organization, they are struggling with thermal, we can come in and support, and we can do thermal analysis with our own software or other softwares if that's needed, because we have also people that have expertise in thermal analysis. But that responding the question, did you have any particular question about the company or?
I would ask some more details, but it's okay.
Okay, we can talk later. If you have more questions, I'm happy to respond.
Sorry,
No, I'm happy to respond. If you have any more questions or later, whatever. Okay.
Is there any more question for Laura? Maybe we can see if there is any question in the chat.
I totally forgot about this. Is there any questions in the chat? Where's the chat? Hi, everyone. Oh, no. Okay, looks like there's no questions there.
Then if not, let's thanks Laura again for. Then, as he said, if you have any question, anything regarding the software, whatever, or Hypatia, you can in the pizza, then you can ask her. Thanks.